Okay, so let's talk about 5.2, some extra power polynomial functions. So we talked about quadratics. Quadratic functions are considered polynomial functions, and so are the linear equations. This one talks about all the other powers. So first, let's talk about the different names. Like when you have a function that is just a number and it doesn't have x's, it's called a constant function. The degree of a constant function is 0. The leading coefficient is going to be that number that you have. So in this case, it would be 2. Then we have a linear function, which we've gone over. The degree of a linear function is 1. Now, when we talk about degree, we're talking about the highest power. And when we talk about leading coefficient, is the number next to the highest power. So in a linear, the degree is 1 and the leading coefficient would be 5 because it's the number next to that x. The next one is a quadratic. The degree or the highest power is 2 and the leading coefficient would be that 4 next to that x squared. The next one is a cubic. The highest power is 3, so that's the degree, and then the 2 would be the leading coefficient right next to it. And then this one is a 4. It can be called a quartic, or you can start calling them polynomials. All of them are polynomials, but at some point we just call, if it's a very high degree, you can call them polynomials. The highest degree, the degree is 4, and the leading coefficient would be 1 because there's nothing next to the x to. We talked about x-intercepts and y-intercepts, so I'm not going to go over too much on that. Now, a polynomial of degree n has at most n x-intercepts and n minus 1 turning points. So find the degree of the following terms, and we'll talk about that as we're working on some examples later on, but the degree is always the highest power of the term, so in this case it would be 6. In this one, it would be 9. In this one, there's no x, so it would be 0. This would be 8. Now, for the whole polynomial, the degree is the highest power of all of them. So in this case, it would be 9. Find the degree and the leading coefficient and the maximum number of real zeros. So the degree is the highest power. So in this case, it would be the 5. The leading coefficient is that number next to it. So it would be -3. If it has a minus next to the number, do carry it down. The maximum number of 0 is always the same as the degree. So in this one, the highest power is the 5. So that would be the number of zeros as well. And the leading coefficient would be -4. This one's a parabola, so we know that the degree would be 2. We cannot tell anything about the leading coefficient, but we know that the number of zeros would be 2 as well. And then we go into some examples that says here, what is the least possible degree of the graph of the polynomial? So what you're going to do is you're going to look at those terms that it has. I think that's what they were asking for number 4 too. Well, this one, it's a parabola, so we know it's going to be 2. This one, they're both going up, so we know it's going to be an even degree. it's not 2. Now we do have this little thing means that's 2 zeros, and then these here would have this turning points here give you 2 more, so it would be 4. If you look at this one, it would be 1, 2, 3, 4, 5. So we're looking kind of like the x-intercepts. This one doesn't have any, but you could see that if we move it down, you could find some there, some of the turning points. This is the chart that I was referring to with even exponents. This chart you can use to determine the end behavior of the graph. These are a little off, but the end behavior of the graph comes from these little charts here. And the way I read it is this here up here is the degree. So either even or odd. And then over here is the leading coefficient. So the leading coefficient is positive or negative. And then that's how you answer the question. Like for example, on this one, you look at the highest power, which is 5. So the degree is 5, which is odd. The leading coefficient is 5. So it's positive. So you are looking at odd and positive. So that would be this one. Now the way you write it on, the way you're going to see it on the choices, it would be like something like this. We'll label this A, B, C, and D. So it would be either, sometimes you see it as false left, right says right, or you see the little arrows pointing in the different directions. The degree on letter B is 3 and the leading coefficient is -4. So in this one, it would go like that. C, the degree is 6 and the leading coefficient is 9. When the degree is even, like here, I think of a parabola. So if your A is positive, the parabola goes up. And then D, the degree is 10 and the leading coefficient is -5. So it would be, it's even. So it's kind of like a parabola where it goes like that, but you don't put the arrows all the way. So it looks like that. And then some of the questions from my open math, you see them like this. Describe the end behavior of the following graph. This is even, so it would look like this. Now, if it's going up, you have positive infinity. If it was coming down, you would put negative. So this refers to the left side. So on the left side is going up, so it's going to positive infinity. This one refers to the right side, going up, so again, positive infinity. 9, it's positive, so it goes like that. On the left, if it's coming down, is negative. If it goes up, is positive. So this one would be negative, and then positive. The degree here is 7, and it's negative, so it's going to come down like that. So on the left, it's positive, and on the right, it's negative. The degree is 8. The leading coefficient is 5, so it's going to go like this. So it's positive on both. The degree is 4 with a negative comes down. So it would be negative on both. Coming down because it's the degree is odd. And the leading coefficient is negative. So on the left side would be going up, and on the right side it would be coming down. I am using the chart to do this. So you do find some way to learn that as you work on these problems, because I will not provide this for the midterm. I do think when it's even, I do think of parabola. And when it's odd, I think of lines and slope. So that's what helps me to remember the chart. But the whole section is based back on this chart.